Is it always moving to the right?
Let's see.
Yeah.
Yes. Okay, so what could we write? Let's answer the first question. Where is the particle moving to the left? So the particle never moves to the left. Okay, because?
V of t will never be less than 0.
V of t is never less than 0. Okay, meaning that the velocity is never negative, right? Okay, where is it moving to the right? Particle is moving to the right on what interval? Or maybe instead of on, we can say when. What do they say when? When t is what? Greater than or equal to 0? Yeah? Because? V of t is what?
Where wouldn't you just put greater than 0? Because at 0 you don't really know if it's moving to the left or right.
We don't? What happens when I plug in 0?
You get 0, so you can't really determine.
I get 2 times 4 squared.
Oh, down.
I don't get 0.
I went bad. I break.
I get 16 times 2, which is 32. Is a positive value? At 0, is it moving to the right? Yes. Okay, and I'm only including it because it tells me to include it there. Be careful. Good looking out there, Pablo.
Yeah, I know. I tried to.
It's okay. At least you're thinking about those particular areas to watch out for, which is a good thing to do. But in this case, it is moving to the right at 0. Okay. Any questions? No? Pretty easy? Alright, so let's look at a couple more examples. Different ways the questions could be asked. Right? These are all from old AP questions. This is from 1998. Okay. Maybe before you were born? Yes? That was the last time the Falcons were in the Super Bowl? I don't know. It was? Oh well. Maybe another 10 years. Okay, anyways, so this question was modified from the way it was asked on the AP test because, again, there's parts there that we haven't talked about, so you can't answer the way you need to answer them. But looking at this, it says the graph of the velocity in feet per second of a car traveling on a straight road for 0 to 50 seconds is shown below. A table of values for V of t at 5-second intervals is also shown to the right. Okay, so they gave us the table so we know exactly what the velocity was at those moments in time. This is kind of hard to determine it from the graph. So again, pay attention to what they're giving you. It's velocity, and it's in feet per what? Per second. Okay? Is this car moving pretty fast or no? It moves 72 feet in 50 seconds. Is that fast or is that slow?
Good, so pretty.
That would be how many miles per hour?
Like 45.
How many feet in a mile?
5,280.
5,280?
Yes.
How many seconds in a minute? 60? How many minutes in an hour? 60? How many seconds in an hour?
A lot.
60 plus 60.
316 squared.
3,600? So you can do it. You can do a conversion, right, Martin?
Yeah.
And figure out how many miles per hour he was going.
Yeah.
Stoichiometry. All right. Anyway, we'll do that on another day. So, during what intervals of time is the acceleration positive? So I'm looking for acceleration. Acceleration would be what? It would be the derivative of this graph, right? So I have to look at this graph not as positives or negatives, but imagining tangent lines on it, right? Or looking at it as if it were increasing or decreasing, right? Alright, so if we want acceleration, that means that v prime of t, which is the derivative of this guy, has to be greater than 0, right? And if the first derivative is positive, what does that tell you about whatever you got the first derivative of?
It's increasing.
Is increasing. So we want to know, where is this graph increasing? Or where would I have positive tangent lines? What could we say?
0 to 35.
A of t is greater than 0, the acceleration is positive, on what interval?
Okay, yeah.
0
also here.
to what?
35.
35? Okay, in union with 45 to 50? Because? So from here all the way to there, in union with from there to there? Because v of t is increased. Super easy? Right. Find the average acceleration of the car over the interval 0 to 50, indicate your units of measure. How would I find average acceleration? A rock. So that would be A rock, the average rate of change of acceleration? Of velocity, right? So if I find the average rate of change of velocity, that's actually giving me the average what? Acceleration. Alright. So average acceleration. What's going to be the formula for that? Do the setup for me. V of
I
what?
like how it's here.
V of 50 minus V of 0 over 50 minus 0. It's like finding the slope of the secant line on the velocity graph, right? That's going to give me the average acceleration over that time period, from 0 to 50. On average, how fast was he accelerating? What do we get? What's V of 50? Do we have to guess?
No.
No, we have a table, right? So 72 over 50?
Yeah.
Do I have to reduce that? No. Could I possibly make a mistake reducing it?
Yes.
And then get that part wrong and not get the point for the answer?
Yeah.
Yes. So don't. Just stop right there. 72 over 50, and what would be my units?
Oh, feet.
Feet per second squared? Y squared? Acceleration. Rate of a rate. Alright, cool. Part C. Find one approximation for the acceleration of the car at t equals 40. So I want acceleration at a moment in time. That's like instantaneous rate of change, right? Show the computations you use to arrive at your answer and indicate the units of measure. So at 40, I know the velocity is what? 75, but I want to estimate the average rate of change, the rate of change. So at 40, it's like me asking you to find the slope of the what there? Of the tangent line. So what could I do to find the slope of that tangent line there? Or at least estimate it. You know that it should be what? Should be negative, right? Why does it say one approximation?
Using the A-Rock of 35 and...
So I could use the A-Rock of 35 and 45?
Yeah.
Could I also use the A-Rock of 40 and 45?
Yeah.
Could I also use the A-Rock of 35 and 40?
Yeah.
Yes? So that's why the question says find what? One approximation, right? You want to use 2 points that are close to each other or close to that particular point that you want and estimate it with that. Those would be the 3 acceptable answers on the AP test. The 2 around it, these 2 together, or those 2 together. Anything else they wouldn't accept. Okay? So which ones do you want to use? 35 and 45? Alright, we'll use that one. Somebody said 40 and 45. That would be acceptable as well. Okay? Most commonly kids pick those 2 around it. Okay? So let's do it. Let's find the acceleration at 40, which would be equal to the derivative of the velocity at 40, which is going to be approximately what? How can I find v prime at 40? V of 45 minus v of 35 over 45 minus 35. So v of 45 was what, 60? Minus 81 over 10? What's 60 minus 81? 21. So negative 21 over 10? And what would be my units here?
Meters per second.
Feet per second?
Too much fit.
Meters per second?
Too much physics.
Too much physics? So what can you tell me about the speed of the car? Is it increasing or decreasing at t equals 4? Is it decreasing? Or is it increasing? What would I have to compare to know that? The signs, right? So I would have to know v of 4. Do I know? I mean, not 4, 40. What's v of 40? 75. Where did you get that from? From the table, right? And that's feet per second. And what's a of 40? Negative 21 over 10 feet per second squared. We approximated that, right? But we do know it's negative. So when I compare the velocity and the acceleration, they have what? Different signs. So that means it's a force going in one way and a force going in another way, causing the object to what? To decrease in speed, right? So what could we say? The speed of the car, not here. The speed of the car is decreasing at t equals 40 seconds because what? V of 40 and A of 40 have different signs. That's it. That's a good enough justification for the credit for that particular. Too easy?
Yeah.
You had enough?
Yes.
You want me to do more examples? I'm sorry. Do we need more examples? Are you sure? 'Cause I got some more. Yes?
I think I'd run.
It won't hurt, right?
I would run.
You got it, Martin?
I don't escape.
Alright, so this was from 2000. And this is question number 2. So on question number 1 and number 2 on the AP test, you are allowed to use the calculator. Okay, so if you came in and you got your calculator, great. If you didn't, well then too bad. And to follow along. Okay? So it says 2 runners, A and B, run on a straight racetrack for 0 to 10 seconds. The graph below consists of 2 line segments showing velocity in meters per second of runner A. So this is only the graph of who? Of runner A's what? Velocity. So it's telling us the direction that the runner is moving and the rate at which he's moving, right? So in which direction is this runner moving? To the right or to the left? He's moving to the right. How do I know he's moving to the left? To the right. Says the velocity is always positive. It's above the axis, right? Good? Alright. At what velocity is he moving at 5 seconds? What is his velocity at 5 seconds? 0?
10.
Or 10? 10? So his velocity is this graph, right? What is his velocity? 10, right? Okay. What is his velocity at 9 seconds? 10. So what does it look like this guy did when he started the race? He accelerated up until he reached his maximum velocity, right? Maybe he can't run any faster than that. And he's running at a constant rate. So is he accelerating up here? No. Okay, cool. Awesome. So he's always moving to the right. Did he ever stop? No, when was his velocity 0 only?
Only started.
At the starting, right? Okay, great. Find the velocity of runner A. Oh, wait. The velocity in meters per second of runner B is given by this function, right? So this function is for the second run. They didn't give us an equation, a graph, they gave us an equation for it. Okay. Good? Alright. Here we go. Find the velocity of runner A and the velocity of runner B at t equals 2 seconds. Okay. So let's do runner A first. Is that when we have a graph, right? So we want v of 2. So what does that mean? Go to the graph, go to 2, and then find it. Like right there. It's 6. Maybe 7. Maybe 6.5.
6.5. Yeah.
Should we just guess? Or should we actually find the exact velocity?
6.5.
I think we should find the exact one. How would we do that?
What's wrong?
Do the AROC? That would be like finding the rate of change of velocity. That would be acceleration. We actually want this value.